Leave a piece of meat on a kitchen counter, and within a few days, bacteria will have made it unrecognizable. Biology is relentless about breaking down soft tissue, and stopping that process is genuinely difficult, even with modern refrigeration and preservatives. Now, picture stopping it so completely that a human body remains intact, with skin, hair, and identifiable features, for 3,000 years, using nothing but oils, resins, and fats, in a hot climate with no understanding of germ theory, bacteria, or organic chemistry, as we would recognize it. That is roughly what ancient Egyptian embalmers achieved, and for most of the last 2 centuries, the specifics of how they did it were assumed rather than known. Egyptologists could read the words for the substances in surviving texts, but nobody had definitively matched those words to the actual chemicals. Then a workshop was excavated at Saqqara, and it turned out several of the translations everyone had been using for over 100 years were wrong. The site itself was only discovered in 2016 in the necropolis at Saqqara, not far from the Pyramid of Unas. It was an underground embalming workshop dating to roughly the 7th and 6th centuries BCE during Egypt's 26th dynasty, and the important thing about it was not the architecture, it was the pottery. Excavators recovered a large collection of ceramic vessels that had been used in the actual embalming process, and many of those vessels still carried their original inscriptions, labels naming what was inside them, and in some cases, instructions describing what to do with the contents. That combination is rare enough to be genuinely valuable. A labeled jar with residue still inside it is effectively a chemical sample paired with its own ancient description, which means a modern researcher can test what is physically there and compare it directly against what the Egyptians themselves called it. In February of 2023, a team of researchers from LMU Munich and the University of Tübingen, working with Egyptian colleagues, published exactly that analysis in the journal Nature. They examined the organic residues preserved in 31 of the recovered vessels using biomolecular techniques, identifying the actual compounds absorbed into the ceramic, and then cross-referenced those results against the labels written on the outside. The chemical picture that emerged was sophisticated in a way that suggests deliberate, tested formulation rather than ritual guesswork. The vessels contained beeswax, animal fats, plant oils including cedar, juniper, and cypress, along with pistachio resin and bitumen. Several of those substances have genuine antibacterial or antifungal properties, and several act as sealants that block moisture and air from reaching tissue. In other words, the mixtures were not arbitrary, they were doing the two things that actually matter for preservation: suppressing microbial growth and sealing the body off from the environment. More striking still, the labels indicated that different mixtures were intended for different parts of the body. Specific preparations were designated for treating the head, others for washing the body, others for softening the skin, others for treating the stomach or the liver. This was not one universal embalming fluid applied everywhere. It was a set of specialized formulations, each matched to a particular task, which implies an accumulated body of practical knowledge about what worked where. Then there is the part that upended existing scholarship. Two words appear constantly in Egyptian funerary and ritual texts: antiu and sefet. The word antiu occurs thousands of times across surviving Egyptian sources, and for well over a century, Egyptologists had translated it as myrrh, or sometimes more loosely as incense. Sefet was understood to be one of the 7 sacred oils, a ritual substance of some importance but uncertain composition. The residues told a different story. Vessels explicitly labelled antiu at Saqqara did not contain myrrh at all. They contained mixtures based on oil or tar derived from cedar, juniper, or cypress, combined with animal fats. Vessels labelled sefet contained scented fat-based ointments with plant additives. In some cases, juniper or cypress resin mixed with animal fat, and in one case, animal fat combined with elemi, a fragrant tropical resin. That is a genuinely significant correction. It means that a term appearing thousands of times throughout the Egyptian written record and translated one way in academic literature for more than 100 years was describing something chemically different from what scholars assumed. Every text mentioning antiu now potentially reads differently, and it took chemical analysis of physical residue, rather than further study of the texts themselves, to catch it. The final finding pushed the story well beyond Egypt entirely. Alongside the substances that would be expected from regional sources, cedar and pistachio resin and bitumen, most likely arriving from the Levant, the team identified 2 resins that do not come from anywhere near Egypt. One was elemi, the other was dama gum, which comes from trees in the Dipterocarpaceae family, growing primarily in the forests of Southeast Asia and Indonesia. Dama had no local source. For it to end up in an embalming jar at Saqqara in the 6th century BCE, it had to be transported across an enormous distance through a chain of trade connections spanning from Southeast Asia to the Nile. The researchers argued that this represents direct physical evidence that Egyptian embalming depended on long-distance trade networks far more extensive than previously documented for that period, and that demand for specific mummification ingredients may itself have been one of the pressures driving those networks into existence. That reframing is worth sitting with. Mummification is usually presented as an inward-facing religious practice, something Egypt did for spiritual reasons in isolation. The chemistry suggests it was also a demand engine, a specialized industry requiring particular materials that could not be sourced locally, sustained by supply chains reaching thousands of miles across Asia and Africa, roughly 2,500 years ago. None of this means the embalmers understood why their mixtures worked. They had no concept of bacteria, no theory of decomposition, no way to isolate an antimicrobial compound and test it against a control. What they had instead was an enormous accumulated dataset, generations of practitioners performing the same procedure repeatedly, observing which bodies held up and which did not, and refining the recipe accordingly. That is empirical method without the formal framework, and applied across enough centuries, it converged on genuinely effective chemistry. The next time a food label lists a preservative nobody can pronounce, it is worth remembering that the same underlying problem, stopping biology from reclaiming organic material, was being solved in an underground workshop at Saqqara using cedar tar, beeswax, and a tree resin that had travelled halfway around the world to get there.